I know you're probably upset to be watching a second video, but I promise you I'll keep this one short. I just ran out of time on the other one, and there's still one more topic, which is Venn diagrams, but they're really fun. You'll enjoy it. I'll keep it short. Okay, Venn diagrams. We've talked about these. We did some activities in the first week with Venn diagrams. They show the relationships between different sets of data, but it's really interesting to think about Venn diagrams in relation to conditional statements. So usually we will draw a circle, and every point in the circle belongs to the set. Every point out of the circle does not. But what's interesting is if-then statements are very easy to put in a Venn diagram. So if we said something like, if it is a rose, then it is a flower, that means all roses are flowers. If they are parallel lines, they do not intersect. That means all parallel lines do not intersect. If they are right angles, it means they are congruent. All right angles are congruent to each other. And so you can see that it is a good way to visualize a true conditional statement is to think of it in terms of a Venn diagram. Okay, so now the last thing we're going to do is something a little more creative with Venn diagrams. I'm posing this problem to you. At Walnut Ridge High School, 34 students take biology, 24 take French, 37 take geometry. 12 take both geometry and biology, 14 take geometry and French, and 16 take French and biology. 10 take all three. How many students take geometry but not French or biology? And I will argue to you that a Venn diagram can help you very easily solve this problem, and I'll also argue to you that you need to know how to do it because it's going to be on the test. So what I'd like you to do right now is pause the video and try to work this out. This isn't going to do you any good if you just keep playing the video and watch me do it. You're going to understand it better if you try to work it out on your own first. Once you've tried to figure it out, then restart the video and I'll show you how I solved it. So just read it carefully, think critically, and then do your best and restart. All right, so hopefully you've solved this. I'm going to show you how to do it. All right, so I'm going to draw myself a Venn diagram that has 3 circles. All right. And this is Walnut Ridge High School. And this is my whoa! Oh my gosh. This is my biology circle. Should do it in different colors, but I'm not going to. This is my French circle. And this is my geometry circle. And I am not even going to read any of this beginning information. I'm going to the last piece of information I was given. Because if you tell me 34 take biology, well, I don't know how many of them are also in geometry and biology and French or all 3. It's too confusing to try to figure out. So you really kind of work these problems from the inside out. I'm going to start with this piece of data. 10 students take all 3. There's only one spot that is all 3, so I'm putting it right here, and I know that 10 students take all 3. I know that for a fact. I know that 10 goes there. Now I'm going to back up a little bit. It says 16 take French and biology. Okay. French and biology, I am going to have to change pen colors to show you what I'm talking about here. I'll just use a highlighter for a minute. French and biology, if you will bear with me, is this area right here, right? This area represents French and biology. But they just told me, let me make sure I'm still on the pen. Okay, they just told me that it's 16 students take French and biology. But I already have 10 in the French and biology quadrant. So how many left does that mean need to go here? If it's 16 total, but I already have 10 written, then there's 6 more that are there. And now I've handled this piece of information, and I've handled this piece. Let's keep going. 14 take geometry in French. Well, geometry in French, do an orange maybe. Geometry in French is this area right here, right? It's this whole area. I don't want to cover up that 10 so you can't see it, but that's geometry in French. So if I am trying to figure out how many kids go in this part. 14 take geometry and French, but I've still got this magic 10 in the middle. That leaves me only 4 left because this whole area can only be 14 in my geometry French area. Okay, 12 take geometry and biology. This is my geometry biology area. I already have this magic 10 in the middle, so I have 2 more that I can put here. So 12 geometry and biology, 16 French and biology, 14 geometry and French. Great. Now let's go up to the big numbers. 37 students total take geometry. Well, I already have, and I'm going to change pen color again because I think it's getting hard to see. I already have 2 here, 10 here, and 4 here in my geometry circle. Do you see that? Those are in my geometry circle. 2 plus 10 is 12, plus 4 is 16. I already have 16 students accounted for in geometry, but 37 total take it. So if I do 37 and I subtract 16, I'm left with 21 that should go here in the only geometry bubble. So 21 plus 2 is 23, 33, 37. That gets me to the total number that take geometry, and I have the right amount in every quadrant. Okay, 24 take French. Well, here's my French area. I already have 6 and 10, which is 16, and 4, which is 20. I already have 20 in the French area, but there's 24 total, so there must be 4 that only take French. And then if I come here and I see that 34 students take biology, well, let's look at my biology circle. 6 plus 10 is 16 plus 2. 18 students are already taking biology. But 34 total take biology, so a lot must take only biology. So if I subtract it, you can see that 16 kids are taking only biology. And if I add those together, 16, 22, 32, 34, that gets me to the 34 total students that take biology. So now I have a completely filled in Venn diagram. And if I'm being asked how many take geometry, but not French or biology, my answer would be 21, because only 21 are in this part of the circle, but not in any of the parts that include French and biology. Play this back if it didn't make sense. You need to understand how to do this, and you can, of course, always ask me questions in class if it's still confusing. But this kind of logic, starting in the middle and moving out, is the way to solve these sorts of complex Venn diagram problems. So, sorry about the 2 videos. See you tomorrow.